So here we're going to talk about increasing, decreasing, and constant functions. So first definition is f is increasing on an interval if for any x1 less than x2, we have f of x1, the function evaluated at that point is less than f of x2. So what does this look like graphically? Okay, so say I've got some function and it looks like this, okay? So maybe this point right here is x1 and this is the graph of f, and then this would be like x2. Well, x2 is greater than x1 here, and then you see that this output f of x1 is less than this output f of x2, okay? So maybe this number is 5, whereas this number was only 2. All right, so that's the idea. Increasing, we're going up when we go from left to right. Okay, so that would be an example of increasing. All right, the next definition would be for decreasing. F is decreasing on an interval for any x1 less than x2, then f of x1 is greater than f of x2. So it's the opposite of increasing. So it would be like this scenario here. Okay? So like right here, maybe this is my x1, and then here's my x2. So your x2 is greater, but the f of x2, maybe that value is now 1, and then this f of x1 is now like 4. Okay? So as you go through time reading left to right, you're actually going downhill. Okay? So that's decreasing. Right? Difference between increasing and decreasing. What's going down in value is the y value. Okay? It's the y values that are going down. All right? All right, the last option is you could be increasing, you could be decreasing, or you can be constant. But it has to be one of those three things, okay, if you're a continuous function. Or at least continuous on that interval. So say we have this interval, okay, and no matter what x value I pick, the output is always the same. So here's the same, here's the same, anything in between is the same. So what is the scenario here? This would be the scenario of being constant all the time. We're not going up, we're not going down. We're just constant on this interval here. So those are the three ideas: increasing, decreasing, and constant. Okay? And so what we're concerned with is figuring out, okay, where are these functions increasing? Where are they constant? Where are they decreasing? So truly all you're doing is you're looking at how is the y value changing. And since you're looking at how it's changing, we're dealing with open intervals. So like a value from like open interval of 5 to 7. Okay, so x values from x equals 5 to x equals 7. All right, so that would be an open interval. So things that are not like a closed interval would be if I had a bracket 5 to 7. Okay, so that's not what we're dealing with. Okay, the reason we don't include the endpoint is because on the endpoint, if you're just including that endpoint, how do you know that at right here that it's decreasing, or heck, it could be increasing, or maybe it's constant, right? So unless you know more information than just looking at an endpoint, you can't know. You got to know what both sides look like in order to be able to say here, okay, is it increasing, decreasing, or constant? It's got to be on this open interval idea here. Okay. All right. So I won't get too caught down in the details, but there's some nuances in there, so don't worry about that. All right. So let's do an example and say that I want to determine the opened intervals where f is increasing, decreasing, or constant. Of f of x equals parentheses x minus 2 squared minus 1. Now, sometimes you might see it written as the intervals of monotonicity. Monotonicity, this is a fancy way of saying where is it increasing, where is it decreasing, where is it constant. Okay, so if you see that in your homework, don't freak out. That's just a fancy way to say where are we increasing, where are we decreasing. So for us, it's probably easiest if we just graph it. So that's what I'm going to do. So I'm going to graph this. And what is this telling me to do? It's telling me that I'm a parabola. Okay, this squared tells me I'm a parabola. The -2 on the inside tells me to go to the right 2. The -1 on the outside tells me to go down 1. Okay, so I go over 1, 2, and I go down 1, and that's the vertex. So the vertex is 2, -1. Now, it's either going to open up like this or it's going to be sad like that. How do we tell? The coefficient in front, the a, is a +1. If we're positive, we're smiling, concave up. And so we look like this. All right? Now, the question is, where are we increasing, where are we decreasing, what intervals? So increasing, decreasing, and constant. Very similar. So where am I going up? If I read from left to right. So this looks like as I'm reading from left to right, I'm going down. So it looks like from -infinity, so from -infinity over to 1, 2, so x equal to 2, that's where I am decreasing, okay? So one common mistake that I see students, they say, okay, it looks like we're decreasing from -infinity up here all the way down to -1 down here. And that's looking at the y value. What you're doing is you're trying to find the x interval where it's decreasing. Okay, so we're decreasing for all these x's going down this way. So it goes from -infinity to 2. But we don't touch at 2, okay? And then we get to the other side, and it looks like on the other side of 2, as we go to the right, it looks like we're increasing. So from this way onward, so from 2 to infinity, we're increasing, okay? So if you're having trouble understanding this, then the easiest way to think about it is think an open interval has no brackets. So a big mistake I see is people put brackets on this part here. There are no brackets on these answers, okay? Now, where is it constant? Is there anywhere where it comes down and then it just stays straight and then it shoots up? No, there are no constants here. So I'm just going to put NA. Okay? So NA, not applicable. Or you can write none. Or you can write nada. Whatever. Okay? Just make sure you tell me. Don't leave it blank because then I'm just going to assume, well, you didn't know what to do. So you put one of those things there. So put one of these answers there. Not applicable, none, there is none, no constant part, whatever. But tell me, okay? Don't just leave it blank. That's not good enough. All right. So just to make sure we've got increasing and decreasing down, I'm going to do one where I have like a big old graph. And this is going to be kind of silly. So you can just watch this. Don't try to copy trace it, okay? So say we have our y-axis and we've got our x-axis. So this is x-axis, y-axis, and now I'm going to do a function. I'm going to start here and I'm going to go up to this point, and then I'm going to go over, and then I'm going to go down, and then I'm going to go just like this. Okay, and we'll have an arrow going that way. So it starts, so we start here and there's no arrow, right? And then this thing goes forever in that direction there. So what I want to know is, where is it increasing? Where is it decreasing? And so I'm going to mark these values that seem important. And we're just going to count by ones. Okay? So -1, -2, -3, -4, -5, -6, -7, and 1, 2, -1, -2, 1, 2, 3, 4, 5, 6, ... forever and ever. All right. So increasing. Where are we increasing? What intervals are we increasing on? Well, it looks like the only place that we're going uphill. Remember, we read from left to right, okay? So where are we increasing? That's how we read, left to right. Always think, how do I read left to right? So where am I increasing? It looks like I'm increasing from here to here. Okay, that looks like it's the only place that we're increasing. So what is that? Well, I look and I say, what interval on which, what x values, right? So I'm looking, increasing interval, those are my x's, okay? That's the where, all right? So where does it go from? It goes from -7 to 3 is where I'm increasing. Those are my increasing intervals. So from -7 to -3, that's where I increase. What about decrease? Okay, so what about decreasing? So decreasing, okay, it looks like over here, it looks like I'm going down. All right, so I'm going down there. So what x values are those? Looks like -1, 2, 3. Everything here is open parentheses. Y'all see that? In my last scenario is, where am I constant? Okay, where is it constant at? Well, it looks like it's constant here, but it also looks like it's constant over there, okay? So what are my values here? Well, it goes from -3 to -1, constant. But then it skips some stuff, so I'm going to do a union. And then where it starts back constant is at 3 off 2, and then that arrow tells me it goes to positive infinity. Okay? So hopefully that gives you an better idea how to tell, where a function is increasing, where it's decreasing. Read left to right, and you're writing down the x values, okay? And you're using the parentheses. You're not going to use brackets, all right?